All right, today we're putting on our detective hats to solve a really cool scientific mystery, one that's happening all around us, all the time. We're about to crack the case of the dancing particles.
You know exactly what I'm talking about, right? A single beam of sunlight slices through a room, and suddenly you see them, these tiny little specks of dust, just dancing. They're not just falling, they're jiggling and darting all over the place, like they're alive. So what's going on? What's making them move like that?
So let's start our investigation right there by just looking closer at this bizarre little dance. We're going to observe what's happening and try to figure out what we're really seeing.
Now here's where it gets really interesting. This doesn't just happen with dust in the air. If you were to take a single grain of pollen, put it in a drop of water, and look at it under a microscope, you'd see the exact same thing. That pollen grain doesn't just sit there. Nope, it zigs, it zags, and it jerks around in a totally unpredictable way.
This mysterious, herky-jerky movement actually has a name. It's called Brownian motion. That's the official scientific term for this random dance that microscopic particles do when they're just hanging out in a fluid. And by the way, in science, fluid just means a liquid or a gas. And this path right here, this shows you exactly what it looks like. Just look at it. There's no rhyme or reason, no clear direction. It just changes course constantly, totally at random. It's pure chaos, just on a microscopic scale. So, our first clue is pretty clear. Whatever's happening, it's completely random. Okay, so if the particles are moving, something has to be pushing them. That's just physics. So for the next part of our mystery, we have to ask, who or what are the invisible pushers behind all this chaos?
And this really is the key question, isn't it? A speck of dust, or grain of pollen, while tiny to you and me, is actually a huge boulder on the microscopic scale. So what invisible force could possibly be strong enough to shove it around so randomly?
Well, to solve this, you need to understand the two different characters in this play. First, you've got our main player, the pollen or dust particle that we can actually see. But then you've got the hidden movers, the billions upon billions of even tinier atoms and molecules that make up the water or air all around it. We can't see them at all, but as we're about to find out, they are never, ever still.
So here's how the pushing actually happens. Imagine our big pollen grain just sitting there. It's completely surrounded by millions of super-fast invisible water molecules, all zipping around like crazy. They are constantly smashing into the pollen grain from every single direction. Now, if the hits were perfectly even on all sides, nothing would happen. But, and this is the key, because their movement is random, at any given split second, a few more molecules will just happen to hit, say, the left side than the right side. And that tiny, unbalanced force is enough to give the pollen a little nudge. A moment later, the imbalance is somewhere else, and whoop, it gets pushed in a totally new direction.
You know, a really great way to picture this is to imagine a giant beach ball at a packed concert. It's being passed over the crowd. Now, you can't see the individual hands pushing it, you can only see the ball. But the ball is getting bumped and jostled in every direction, not because any one person is trying to move it, but because of all the random, combined pushes from that whole unseen crowd. That is exactly what's happening to that little pollen grain. So we figured out what's causing the motion. Case closed, right? Well, not quite, because this is where the story gets really, really big. This isn't just some quirky little science fact. This tiny, chaotic dance is visible proof of something absolutely fundamental about how our entire world works. That's right. For a long, long time, the idea that everything, you, me, this planet, is made of tiny, constantly moving particles called atoms was just a theory. A really good one, but a theory nonetheless, because nobody could actually see an atom. Well, Brownian motion changed everything. It was the first time we could actually see the effects of these atoms, making the invisible world visible. And there it is, the solution to our case, laid out plain and simple. That random jiggling of microscopic particles, it's the smoking gun. It is direct, physical evidence for what scientists call the kinetic particle model of matter. We can literally see what atoms do, even if we can't see the atoms themselves. And this is that huge theory in a nutshell. The kinetic particle model says that everything around us, the solid chair you're on, the liquid water you drink, the gas you're breathing, is all made of countless tiny particles. And those particles are never, ever still. They are always in constant chaotic motion. Brownian motion is the proof we can see with our own eyes. So let's wrap up our case file. That random dance of a dust particle, that's Brownian motion. What causes it? A relentless bombardment from smaller, invisible, super-fast atoms and molecules. And what does it all mean? It's the visible proof that our world, deep down, is a sea of constant, chaotic, and invisible energy.
And that just leaves us with one final, kind of mind-bending thought. We've just seen that a drop of water that looks perfectly still to us is actually an arena of chaotic, energetic collisions. So, if even stillness isn't really still, what other powerful, unseen forces are at play all around us, shaping our world in ways we can't even begin to see?